Defining Ethernet standards. Ethernet is far and away the most common type of LAN standard used by today's organizations. It is a scalable technology, but to get the most out of Ethernet, devices, computers, and other hosts should be compatible. This means knowing the various Ethernet standards is very important. Certification ready. Can you identify and describe Ethernet standards? Objective 1.5. Ethernet is a group of networking technologies that define how information is sent and received between network adapters, hubs, switches, and other devices. An open standard, Ethernet, is the de facto standard and has the largest share of networks in place today, with token ring and FDDI filling in the small gaps where Ethernet does not exist. It is standardized by the Institute of Electrical and Electronics Engineers, IEEE 802.3, developed originally by Xerox. It was later championed by DEC, Intel, as well as Xerox. Now, Ethernet products are offered by hundreds of companies, such as D-Link, Linksys, 3Com, HP, and so on. Computers on Ethernet networks communicate by sending Ethernet frames. The frame is a group of bytes packaged by a network adapter for transmission across the network. These frames are created and reside on layer 2 of the technology model, which is covered in more depth in the next lesson. By default, computers on Ethernet networks all share a single channel. Because of this, only one computer can transmit at a time. However, newer networks with more advanced switches transcend this limitation of Ethernet and is covered in more depth in lesson 2. IEEE 802.3 defines carrier sense multiple access with collision detection or carrier sense multiple access with collision detected, CSMA-CD. Because computers on a default Ethernet LAN all share the same channel, CSMA-CD governs the way that computers coexist with limited collisions. The basic steps for CSMA-CD are as follows. Point 1. The network adapter builds and readies a frame for transmission across the network. Point 2. The network adapter checks if the medium, for example, twisted pair cable, is idle. If the medium is not idle, it waits for approximately 10 microseconds. This delay is known as the interframe gap. Point 3. The frame is transmitted across the network. Point 4. The network adapter checks if any collisions occurred. If so, it moves on to the collision detected procedure. Point 5. The network adapter resets any retransmission or counters, if necessary, and ends the transmission of the frame. If a collision was detected in step 4, another procedure called the collision detected procedure is employed. The network adapter continues transmission until the minimum packet time is reached, known as a jam signal. This ensures that all receivers have detected the collision. Point 2. The network adapter increments the retransmission counter. Point 3. The network adapter checks if the maximum number of transmission attempts was reached. If it was, the network adapter aborts its transmission. Point 4. The network adapter calculates and waits a random back-off period based on the number of collisions detected. Finally, the network adapter starts the original procedure at step 1 of the CSMA phase of the CSMA-CD process. If an organization utilizes wireless Ethernet carrier sense multiple access with collision avoidance, CSMA-CA is employed. CSMA-CA is a network multiple access method in which carrier sensing is used, but nodes attempt to avoid collisions by transmitting only when the channel is identified as idle. When nodes do transmit, they transmit their packet data in its entirety. CSMA-CA is particularly important for wireless networks, where the collision detection of CSMA-CD is unreliable due to the hidden node problem. Devices on an Ethernet network must be compatible to a certain extent. If you are using an Ethernet switch, a computer's network adapter must also be of an Ethernet type in order to communicate with it. However, unlike some other networking technologies, different speeds can be negotiated. For example, suppose your switch had a maximum data transfer rate of 100 megabits per second. But your network adapter only connects at 10 megabits per second. The network adapter would still be able with the switch, but at a lesser rate. The various speeds of Ethernet and the cable media they use are defined by the various 802.3 standards listed in table 1.2. Although 802.3 by itself is generally thought of as 10 megabits per second, it is further broken up into various subgroups, as shown in the table. Table 1.2, 802.3 Ethernet standards, 802.3 version, data transfer rate, cable standard, cabling used. These are all 802.3 J, 10 megabits per second, 10 base F, fiber optic, and so on. All of the 10 megabits standards listed are a bit slow for today's network applications, but you might find them in some organizations and in other countries outside the United States. Of course, a good network administrator can make even 10 megabits per second networks run quickly and efficiently. In fact, an efficient 10 megabits per second network can easily outperform a poorly designed 100 megabits per second network. The 10 gigabits per second standards are much newer as of the writing of this book, and therefore are much more expensive. Currently, 1 gigabits per second connections for clients and 10 gigabits per second connections for network backbones are common. The most common cabling standards used today are 100 base TX, 1000 base T. Keep in mind that new standards are constantly being released by the IEEE. 10 megabits per second is typically referred to as Ethernet. 100 megabits per second is known as fast Ethernet. And 1 gigabit per second is known as gigabit Ethernet. 1 gigabit per second is known as a gigabit Ethernet. Lesson 1, page 32, Understanding Local Area Networking. Identifying the differences between client-server and peer-to-peer. Most of today's networks are distributed. This means that CPU power and applications are not centralized, but instead every host has a CPU, and every host can run programs that connect to other computers. The most common types of distributed networks are client, server, and peer-to-peer. It is important to know the differences between these so you can decide which technology is best for any given customer scenario. The older type of computing was known as centralized computing. This was the case during the days of the mainframe, where there was one supercomputer and the rest of the devices that connected to the supercomputer were known as terminals, or dumb terminals. There was typically a keyboard and display with no processing power. Today's computing is known as distributed computing and is used for both client, server, and peer-to-peer networks. This means that every device or workstation has its own processing power. However, in a way, the idea of centralized computing has made a comeback of sorts. Terminal services and remote sessions to computers are based on the centralized computing model. Also, client computing has been slowly achieving market share for the past decade or so. Thin client computers do not have a hard drive. Instead, they store an operating system in RAM, which is loaded up every time the device is turned on. All other applications and data are stored centrally. So in a way, this is sort of blending some centralized computing in with today's distributed computing. Defining the client-server model. The client-server model is an architecture that distributes applications between servers, such as Windows Server 2016 and client computers such as Windows 8, 8.1 or Windows 10. It also distributes the necessary processing power. It is extremely common in today's land, as with most applications that an average user would utilize when connecting to the internet. For example, when users first come into work, they typically log on to the network, Chances are this is a client-server network. They might be using Windows 10 as the client computer to log on to a Microsoft domain, which is controlled by a Windows server. A simple example would be a user at home connecting to the internet. When a user wants to go to a website such as Bing, or the user opens a web browser and types http://www.bing.com/ or one of the many shortcuts. The web browser is the client application. Bing's web server is obviously the server. It serves the web pages filled with highly functional HTML code. The client computer's web browser decodes the HTML code and fills the web browser display with data for both on the job and personal use from the internet from useful resources, such as Microsoft Outlook. Outlook is the client application that connects to a mail server, most likely an SMTP server, perhaps run by a Microsoft Exchange server. The examples are endless, but client-server is not the end all when it comes to networking. Sometimes it is more efficient to not use a server, particularly with a very small number of users. Identifying network topologies and standards. Here are some examples of usages for servers. File server. File server stores files for computers to share. The connection to a file server could be made by browsing, by mapping a network drive, by connecting in the command line, or by connecting with an FTP client. The latter would require special FTP server software to be installed and configured on the file server. By default, Windows Server 2008 and newer can be file server right out of the box. Print server. The print server controls printers that can be connected directly to the server, or and more commonly are connected to the network. The print server can control sorting, desorting, and stopping of documents, as well as concepts such as pooling, printer pooling, ports, and much more. By default, Windows Server 2008 and newer can also be print servers right out of the box. Database server. A database server houses a relational database, one that is made up of one or more files. SQL databases fall into this category. They would require special software such as Microsoft SQL Server. Access databases, which are just one file, would not necessarily require a database server. They would usually be stored on a regular file server. Network controller. A network controller is a server, such as a Microsoft domain controller that oversees user accounts, computer accounts, network time, and the general well-being of the entire domain of computers and users. Windows Server 2016 servers can be domain controllers, but they need to be promoted to that status. By default, the Windows Server operating system is not a controller. Network controller operating systems are also referred to as network operating systems, NOS. Messaging server, this category is enormous. Providing simple services alone would make this a full-time job. But you have to add in fax servers, instant messaging, collaborative and other types of messaging servers. For Windows Server to control email, special software known as Exchange Server needs to be loaded in addition to the operating system. Web server, then you got, I'm going to quit. I'm going to stop reading. But you got the web server, it's the IP-based server. And yeah, that was it. That was it. Then understanding new operating systems is the next topic. Page 34, inshallah, we're going to proceed with that in about an half hour or tomorrow. Tomorrow we'll see. We'll see what we'll do.